So last time I ended the motivation for matrices, which is a simple scenario. You should know that from algebra. That is a linear system. And why do we call it linear? If you rearrange the equations, you will guess y equals -6 plus 5, and the second equation, 2y equals -3x plus 14. Divide by 2 on both sides. Y is -3 over 2x plus 14 divided by 2. Well, that is 7. What do those two equations remind you of? The SAT. The SAT, okay. What topic is that?
I don't remember it, but don't you set them equal to each other? Then why is the same value?
True, that's what we're discussing last time. But if you simply look at this equation, what does that remind you of? Louder, Norman. Fine. Can you hear? No, we're not talking to Friday. No, if you should.
A line.
A line. So that is the equation line. And if you look at both equations, both of them are lines, hence the linear system. Can you find the solution? The solution is simply the point of intersection of two lines. Great. What if you added another variable? X plus y plus z, a third one, and you don't no longer have a line. You rather have a plane. So think of 3 pieces of paper, regular paper intersecting in three-dimensional space. Those 3 points would be the solution to a linear system. And 3 variables, if I add 4 more. If you extend it further and add 4 variables, you are getting into dimensions that are, harder to visualize. With me? Line, easy. Intersection, planes, easy. Think of sheets of paper intersecting at some point. But past that, I can visualize, but I don't want you to confuse yourselves. So our objective is to find that solution. That's what Jag was referring to. In setting them equal to each other, that would mean they intersect at the solution. All the pointers intersection. Good. When I ended, I mentioned this is easy to do. Elimination, substitution, get rid of one of the variables, solve for the other, take the value, put it back in one of the 2 equations, you get the solution. But if you had way too many variables, you cannot, well, you can, but you will feel miserable trying to get a solution. Now, we know vectors, and I refer to the I vector, J vector, long X direction, long Y direction. Yes? I, J. If you want to use the square bracket notation, what would that correspond to? In 2 dimensions. 1, 0. 0, 1. Yes. If you extend it to 3 dimensions, what would we have?
1, 0, 0. 0, 1, 0. 0, 0, 1.
This is something we know. In terms of matrices, we can put those 2 vectors together and represent a unit matrix that corresponds to a 2-dimensional system. You can extend and come up with a matrix that corresponds to a 3-dimensional. Now, what do I mean by that? So I'll call this I2, I2. 2 rows, 2 columns. Good. The I stands for identity. Identity is like the number 1. Anytime you multiply a number by 1, what do you get? The same number, self-identity. So identity matrix for 2 dimensions is simply 1, 0, 0, 1. All I did is took I vector, J vector, and put them together. Good. Extending to 3 dimensions. I vector, J vector, A vector. So as a start position, I look at matrices this way. Because, that's just how things are in real life when you express something. But people do use matrices in physics and engineering. But eventually, when you get to the matrix part of things, you drop the I vector, J vector, K vector. Good. So, is it possible to write an identity matrix in 4 dimensions? So 4 by 4. Yep. I can keep on doing this for 10 dimensions, but we need a computer beyond a certain point. With me so far? The notation for a matrix is always, in most cases, an uppercase letter. Could be A, B, M, W, doesn't matter. And you can see here, I, uppercase I. Good. I'm going to write the left-hand side of the system that I have as a matrix. Good. Do you want to take a guess? So clearly, it's a 2 by 2 case. So 2 rows, 2 columns. Do you want to guess as to what the number is for? Jag was almost there. X3x and y to 1. Good. But matrices with one numbers, you know, in terms of application, so going to isolate the x, y, and I'll tell you how that can be done. So I'm going to get rid of the x, get rid of the y. So the coefficient of x is 1. Then I have 1. So 1, 3, 1, 2. Good. All I did was pick the numbers out. Good. Okay. All okay. Understand? Okay. Now, I want to write the right hand side as a matrix, but then it's not a matrix really. It's a vector, but a vector is a matrix. So how would you write that as a vector? Okay, very good. So I'm going to use the letter B. Lowercase vectors are denoted by lowercase letters. So 5, 14. And if you recall, I mentioned that common practice is to always present matrices, or excuse me, vectors as column vectors. Don't like to write them as row vectors, even though there are uses. But in practice, we always use column vectors. Good? Column vectors, column vectors. So I've got the x part, I've got the b part. Now I want the x vector. Why am I using this notation? This notation is standard. If you Google, this is what you would see in most cases. The x vector will contain the unknown variables. What are the unknown variables in that system? X and y. Good. So the matrix A, 1, 1, 3, 2. Good. The vector x, x, y, right hand side, 5, 14. Good. Let me I'll show you why this makes sense. But this should make sense. Good. So A, X, B. Well, if you have two vectors, how do you find the dot product? What is the very first step that I suggested in finding the dot product? Okay, keep the first one horizontal. What do I do to the second one? Flip, write it vertically. And what is my morbid analogy? run us the cliff and jump. So run, jump. So what do you do as you go along? You multiply the individual components 1 times 3, 2 times 4. What goes in the middle? Good. Yes, no, maybe. Okay. Now, I'm going to run a clip and jump. First try, and then I try again. So, run, jump. If I did, what will I get? Dot product of 1, 1 and x1. You can write it.
X plus y.
Huh?
X plus y.
X plus y, do we agree? 1 times x, 1 times y, and then add. I get the first equation. Good. Second cliff, run, jump, 3 times x, 2 times y, plus in the middle. I get that equation. Yes. So by writing ax equals b, I'm simply referring to the linear system. Obviously, got to start matrix one. So press second and x index. That is going to give you a bunch of names. These are matrix names defined in your calculator. They don't have values, they're just names. So go over to edit. Yes. Select one that is my first matrix, my A matrix, and A is 2 by 2, 2 rows, 2 columns. So 2, 5, 2, 2. Good. Now we just have to fill in the numbers. 1, 1, 3, 2. Good. Second mode to exit. Naturally, what is the next number that you should use? Or vector? Or define an A X. X, but it's got unknowns. B, right? So the next one that I would define would be B. So second matrix. Number 2, which is the matrix B. How many rows does the vector is a matrix? How many rows does it have? 2. How many columns?
1.
Good. Fill in the values. 5, 14. Good. Second mode. I want to start with the easier one, but I'm not going to get into details as to why things are the way they are. Let's keep it simple. Right, this is frequently not matrix algebra. So what I'm going to do, I want to find the value of x, and my equation in terms of matrices, ax equals 2. If that is your equation, and if I ask you how do you solve it, x, what would come to your mind first? Loud and loud.
Divide both sides by A.
Divide both sides by a. Mind you, this is informal. I'm not getting into details, but you can understand. Divide both sides by a. Yes. You move a to the numerator. What would the exponents be? A place -1. Agreed. That is the solution. Yes. Good. Let's see how we can get that. So go back to second matrix. This time I'm not editing, I'm rather selecting. So number 1, A pops up and raised to the power of -1. So X inverse. So click, you get inverse. Good. Go to matrix, select number 2, B. Put this over. Hit enter, you will get the answer. Ready? X is 4. Y is 1. In algebra, your professor would have suggested, well, once you find the solution, how do you verify it?
Plug it in,
Ah,
your solution into the, like, either equation.
you either or both.
How about both?
It has to satisfy both equations. I know this is right because I created it on. So I want you to plug in x is equal to 4, y equals 1 in your linear system and see if they match up. They should, but give it a try. So let's see if we have the correct solution, as I said, that is the correct answer. So we're going to take x, y, which is 4, 1, put it in the first equation, x plus y, 4 plus 1 equals 5. Left hand side is 5, right hand side is 5, but it must satisfy both equations. So plug in 4 and 1 in the second equation. 3 times 4, 12, 2 times 1, 2. Good. So the moment you realize that you've entered everything properly in the calculator and you use the equation properly, you don't have to verify. I'm just doing this so that you know that we found the correct answer. That's all. But if you did these steps properly and evaluated using the calculator, machines do better than humans. For the most part, as long as they are alive. But any questions? Yes, no, maybe, no questions. Okay. How many unknown variables do we have in the system? 3. Instead of calling them X, Y, Z, I call them A, C. Doesn't matter. 3 equations, which would mean you would have to eliminate twice and then substitute too much work. Yes, this is what I want you to try. First, write down the matrix A. Second, write down the matrix B. Put them in the calculator. Do A inverse B. Tell me what the solution is for A, B, C. In this case, your X vector will correspond to the unknown variables A, B, and C. I want you to come up with the matrix A. The matrix B vector. Use that in the calculator and tell me what A, B, C are.
Yes.
First, we've got to construct the matrix A, then the matrix B. Use that expression redundant. Yes. So, how do we form the matrix A? We simply pick out the calculations. As I went along, a couple of you switched the order in the sense you looked at these values and wrote it out 3 minus 3 and 2. Cannot do that. You have to maintain the exact same order. Again, I won't get into theoretical details. So 3, 1, minus 1. First row, minus 1, 3, 2, the second row. Two, 5, 3. Third row, yes. Right inside values would go in the vector B. So 4, 7, and 13. Without getting into theoretical details, I will give you a hint so that you don't make any mistakes. The matrix A, when it's all said and done, you write it out, it has to be a square matrix. In the sense, the number of rows and the number of columns, they have to be the same. Good? Are they? Yes, they are. It has to be a square matrix or else it's not going to work. Good? Okay. Second matrix. The matrix A is 3 by 3. So over to edit. Number 1, 3 rows, 3 columns, and keep entering in the calculator. It's going to go long rows. So 3, 1, negative 1, wrong negative sign. Negative 1, 3, 2, lastly, 2, 5, 3. But, yes. Moving on to matrix B. Edit. Number 2. How many rows do we have? 3. So 3 rows, 1 column. 4, 7, 13. back to matrix. This time we're done editing our matrix. All we have to do is select. So A, raise -1. So -1, type in B or select B. Second matrix, number 2. Ready? Go. 1, 2, 1. And have to verify as long as you enter things. If you have to verify anything at all, go back and check that you entered matrix A under matrix B. Problem. Good. That's all. Now, isn't this easy compared to what you did in algebra? Did someone solve linear systems in algebra? Should have. Very. Yes. Which one do you like better? This or this? Exactly. It's going to take a lot of paper. Don't hate your algebra. As I said, growth and learning happens over time. They don't happen overnight. And we can't talk about matrices in middle school and high school. Good? But do we follow it? Okay. Now, your book gets into 2 approaches. I am going to explain them. But calculator is your friend. Good. I'll show you the concept and the calculator. We're going to stick with the calculator. Good.